Introduction to smart contract deployment. Deploying a smart contract involves compiling the contract code and publishing it to the Ethereum blockchain. Once deployed, the contract becomes immutable and can be interacted with by other users. Setting up the development environment. So the first step we do is install Node.js and npm. So you might have the question, right? What is Node.js and what is npm? Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. It allows developers to run JavaScript on the server side, right? And NPM stands for Node Package Manager, right? And what it is, it's the default package manager for Node.js. It helps in managing and installing packages needed for blockchain development. So in deploying smart contracts, we write deployment scripts in JavaScript and run them using Node.js. And we manage project dependencies and versions with NPM to ensure consistent development environments. The first step in setting up the development of environment is to install Node.js and NPM, which are essential for running the Truffle framework and other development tools. So the next thing you have to do is install Truffle, right? So what is Truffle? Truffle is basically just a popular development environment. It's a testing framework that simplifies writing, testing, and deploying smart contracts. It's an asset pipeline for Ethereum and it is used for deploying smart contracts. You can install it globally using the npm command npm install -g truffle. And finally, you install Ganache. So what is Ganache, you might be asking? Ganache is just a personal Ethereum blockchain, right? So this allows local testing on a personal blockchain. So you can use it to deploy and test your smart contracts locally. So you can install it globally using the npm command npm install -g ganache.client. Writing the deployment script, right? So what we are doing is we have to write a deployment script to automate the deployment process. Truffle, what we mentioned in the previous slide, provides a convenient way to manage deployments using migration scripts. So the analogy we can use here is writing a deployment script is like writing instructions for assembling a piece of furniture, ensuring each step is followed correctly. Okay, so this should be more clear by the code example I present to you. The // migrations to deploy contract.js, right? So this is just the file path. This comment indicates the file path and name of the migration script. In Truffle, migration scripts are usually named with a number prefix. Example, to underscore deploy underscore contracts.js to indicate the order in which they should be executed. The next step is loading the contract. This line loads the compiled version of the smart contract named myContract. The artifacts.require function is provided by Truffle and allows you to reference your smart contract within the migration script. Third is exporting the function. This line exports a function that Truffle will run during the migration process. It takes a single argument deployer, which is an object provided by again Truffle to handle deploying contracts. And finally, we are deploying the contract. In this function, the deployer.deploy method is called with myContract as the argument. This method tells Truffle to deploy the myContract smart contract to the blockchain. So just to clear everything, a migration script in the context of blockchain and Ethereum development is a script that automates the process of deploying smart contracts to the blockchain. It will help you manage the life cycle of contracts, including deploying new versions, updating existing contracts, and migrating data from old contracts to new ones. They're very useful in a development framework like Truffle, which is widely used for building and deploying Ethereum smart contracts. Okay, so deploying to a local blockchain first. Keep in mind, this is a local blockchain we are deploying it to first, not the main blockchain, right? Okay. So it has three steps that are outlined here. First is start Ganache, second is compile contracts, and third is deploy contracts. So let's go through everything. So what we do here is we deploy the smart contract to a local blockchain using Ganache for testing and development purposes. So the analogy that we are using here, so basically to put this in more familiar terms, is like testing a new app on a personal device before releasing it to the public. Whenever there's an app, right, you test it on a personal device first, right? To see if it works properly, to recognize bugs and issues you can find on your own. So this is how it works. So you're deploying it on a local blockchain first, which you own. It's a personal blockchain. So this is where Ganache comes in. So the steps to do this is first you start Ganache with the Ganache dash client function. Then you compile contracts, truffle compile, and then you deploy contracts, truffle migrate, dash dash network development. Next is truffle configuration for a local blockchain. Clarify this again. Truffle is just a popular development framework for Ethereum that provides a suite of tools to help developers build, test, and deploy smart contracts. It simplifies the entire process of managing the development cycle of decentralized applications, right? It helps you in smart contract management, etc. So, Truffle will obviously have a configuration file, which is called the Truffle configuration file. It's called truffle-config.js. This indicates we use it in JavaScript, right? So this is used to specify the settings for deploying and interacting with Ethereum smart contracts. So let's explore this. The configuration file shown in the input sets up a development network with the following parameters. Host 127.0.0.1, this is just the local host, right? And the port being used is 8545. This is the port being used in this scenario in this full configuration file for a local blockchain. And the network ID, we have just put it as star. This configuration tells Truffle to use the local Ethereum node running on 127.0.0.1, right, and 8545 for the development environment. The network ID is set to star to match any network ID, which is a common setting for a local development. Because this is just a local development, so you can match to any network ID. That's why we set it as star instead of specifying the network ID, right? And this is just an additional feature that the Truffle configuration specifies the Solidity compiler version to be used, which in this scenario is 0.8.0, the one you have been using up to now, right? So this ensures that the correct Solidity compiler is used while compiling the smart contract. So the next stage, after you have tested it on a local blockchain, you deploy it to a test net. So deploying the smart contract to a public testnet, examples, there are a few examples of public testnets like Ropsten and Ringwire. So we deploy them here for further testing before deploying it to the mainnet. So the analogy is, okay, you have made an app, right? You tested it on your own device. You have figured it as much as you can, right? But obviously, with all apps, first you might have seen a beta version is released. That's to gather feedback and find bugs and ensure that everything works as expected, right? The most popular apps on the market, Zomato, Swiggy, everything has beta versions. Uber, Zomato, any game you play, everything has a beta version for which you register. And the condition for that is you have to give feedback to the developer. So similar in this analogy, right? In blockchain also, you deploy a contract to a testnet after personal testing on the local blockchain. So this has three steps again. But the first step you have to ensure is you have to obtain testnet ether from a faucet. Basically, to test and deploy your smart contracts on a testnet, you'll need some test ether first, right? And you get these from a source called faucet. So just imagine, even though you're on an imaginary server, right? You have an imaginary app on your testnet, you will still need some money, which is Ether, right? This you get from an imaginary bank, which is called a faucet. So this is imaginary money, which you get from a bank called faucet. This is not actual Ether, this is just called test Ether. So you obtain this testnet Ether, which is used in the testnet from a faucet. So the first thing you have to do is first choose a testnet. Decide which Ethereum testnet you want to use, right? Popular options include Ropsten, Ringwire. There's also Kovan and Gioreli too, if I'm not wrong, right? And different faucets are available for different testnets. And then you have to find a faucet for the testnet you choose. So there's again Ropsten faucet, Ringwire faucet, Kovan faucet, Gioreli faucet. And you get the testnet ether using the instructions on the faucet website, right? Okay. Next, you have to configure Truffle for the testnet. We'll go through it in the next slide. This is what you have to do. Then finally, you deploy contracts using Truffle Migrate Network Ropsten. Okay, so as I told, truffle configuration for testnet. So as there was a configuration file for the local blockchain, truffle config.js, again JavaScript file, is used to set up the deployment settings for different blockchain networks, including testnet environments. Here's an example configuration for deploying to the Ropsten testnet. Example configuration is going to use @truffle backslash /HT wallet provider package to connect to the Ropsten network via Infura. So what is Infura, you might ask? Infura is just a popular Ethereum node provider. As we go through it, I'll explain in more detail what Infura is. Okay. So the Infura key variable holds the project ID for the Infura account, which is required for the connection. So this variable which we are defining called Infura key, it will hold the project ID for the Infura account, which is required for the connection. Okay, I'll just explain what Infura is quickly. Infura is a service that provides access to Ethereum and interplanetary file system networks without requiring developers to run their own nodes, right? So again, it's just a popular Ethereum node provider. So its main key feature of Infura is it basically provides Ethereum nodes as a service. So it provides an API for developers to interact with the Ethereum blockchain. This includes access to the mainnet and various testnets like Ropsten, RinkPy, Kovan, and JRally. So that's how Infura is. You can get to know more about it in detail, but this is just a basic of what Infura is, right? Mnemonic variable holds the 12-word seed phrase for the Ethereum wallet. So you might have heard what Ethereum wallets are, right? There's MetaMask, there are multiple Ethereum wallets. You can find multiple, countless Ethereum wallets, especially with the boom of cryptocurrency in recent years, right? So the mnemonic variable holds the 12 words seed phrase for the Ethereum wallet. This is what the mnemonic variable does, right? It's just a variable. It holds a value, right? And this is the 12-word seed phrase. Okay, so the Ropsten network configuration specifies the provider, the network ID, gas limit, confirmation requirements, and other settings for the Ropsten test. So that's what the Ropsten network configuration specifies, right? And the compiler section again just sets the Solidity compiler version to 0.8.0. Deploy it finally to the mainnet. We have done personal testing, right, on a personal blockchain. We have tested it on the testnet. Now we need to go to the mainnet. So three steps again. And first you have to ensure the contract has been tested well. And then you configure Truffle, how you configured it for personal blockchain and testnet. You configure it for the mainnet to prepare for deployment. And then you deploy, right? Truffle migrate network mainnet. Okay, let's go through this in detail. So deploying to the Ethereum mainnet. So I'll just explain this first. There's going to be a lot of technical jargon here. Please bear with me. When I explain the code to you after going through everything once, I think it should be easier to understand. But okay, let's go. So while you deploy your smart contract on the Ethereum mainnet, you'll need to configure your Truffle project to connect to the mainnet network, right? Again, how you did it in previous for testnet and personal blockchain, right? For testnet and your personal node, right? Okay. So again, this involves setting up the provider, network, ID, gas settings, and other parameters specific to the mainnet environment. Exactly what we did for testnet. In the truffle config.js file, you need to add a new network configuration for the mainnet. So this typically includes the following settings. First would be the provider. A provider that can connect to the Ethereum mainnet, such as Infura or a self-hosted Ethereum node. Again, for testnet also, we used Infura and we'll usually use Infura. Self-hosted Ethereum nodes are there, but Infura is what is commonly used, and at the basic level, we use Infura only. Network ID for the Ethereum mainnet, which is 1. Okay, it's given that Ethereum mainnet's network ID is 1. Next, you have to specify the maximum gas limit for transactions on the mainnet. And this is always typically higher than what happens on a local or a testnet environment. So what you deploy on your mainnet, everyone can see that and interact with your contract. What you put on the testnet or your personal environment, only you can see that or a very specific number of people can see it. Okay, so confirmations, the number of block confirmations required before considering a transaction successful, which is usually set to 2 or more for the mainnet. This is just a good rule of thumb. It's usually two and more, right? So next is the timeout blocks, which is the number of blocks to wait before timing out a transaction. It can be set to a higher value for the mainnet. And dry run is whether to skip the dry run while deploying the contracts, which is typically set to false for the mainnet. In your code, you have to replace it with your own values, right? The mnemonic is the seed phrase of your Ethereum wallet, as I told before, the 12-word seed phrase, and the Infura key is the API key for your Infura project, as I explained. Okay, so here's the explanation of the code. So first would be the provider. This is a function that returns a new instance of HT wallet provider, which is used to sign transactions for addresses derived from a mnemonic, a string of words that generate a deterministic wallet, right? The mnemonic, this variable should contain the mnemonic phrase for the wallet you are using. Infura key, as I told, API key for Infura, a service that provides access to Ethereum nodes. And please remember to replace $Infura key with your actual Infura project ID. The URL https mainnet.infura.io v3 and your Infura project ID specifies the endpoint for Infura's mainnet service. Okay, so the network ID is 1, I told you, right? Gas. So this specifies the maximum amount of gas that will be used for deploying the contract. In this case, we have set it to 55,000. Confirmations. This sets the number of confirmations to wait before deployments. It is set to 2 here. It can be more too, right? It is usually more than 2. And timeout blocks. This specifies the number of blocks to wait before timing out when transactions are not mined. It is set to 200 over here. So skip dry run. Yeah, I'll explain what a dry run is also here. So this Boolean flag, first of all, determines whether to skip the dry run or not before the migrations are deployed. And what is a dry run? A dry run simulates the deployment to check for issues. That's all. It's a dry run, right? You'll simulate the deployment to check for issues. Here, it is set to false, meaning the dry run will not be skipped. So the dry run will happen. So verifying and interacting with your deployed contract. So this has 3 steps again. First, you copy ABI, copy bytecode, and use Etherscan, right? So we verify the contract on Etherscan and interact with it using tools like Remix Ethereum, Web3.js, or Ether.js. Think we'll be doing Web3.js today, right? And the analogy is right. Verifying and interacting with a deployed contract is like you have launched an app on the App Store. You need to verify and interact with it, right? And use it. So you get the contract ABI and bytecode and use Etherscan's contract verification tool. So what is ABI? ABI defines the interface of your smart contract necessary for interacting with it, right? So this is what the function of ABI is. ABI stands for Application Binary Interface. So when you want to interact with a deployed contract, right, example calling functions or listening to events, you need the ABI to understand the contract's interface. So ABI essentially what it does is it defines the interface of your smart contract necessary for interacting with it. Next is bytecode. Bytecode is the compiled binary code that gets deployed to the blockchain. As the name suggests, it's just the code. And what is Etherscan? Etherscan is just a block explorer for Ethereum that provides transparency by allowing you to verify and view contracts. It's a tool you're using to verify and view your contracts. We're going to be interacting with Web3.js. So this is JavaScript, right? So we use the Web3.js, again, JavaScript library to interact with the deployed smart contract. So what you can do is you can create a new Web3 instance and connect it to the Ethereum network using an Infura endpoint, as you have already done, right? Next, you load the application binary interface of the deployed contract and the contract's address, right? You have to load the ABI with the contact's address. Next, you create a new contract instance using the web3.eth.contract method, passing in the ABI and contract address. And finally, you can now call the contract's methods using the myContract.methods object. For example, myContract.methods and myFunction.call, then console.log will call the myFunction method and log the results onto the console. Example of deploying a smart contract, we'll walk through a comprehensive example of deploying a simple smart contract, right? So it's like following a recipe to bake a cake from gathering ingredients to serving the final product to the customer, right? Okay, so this is what we'll go through. I think this should pretty much clear a lot of things for you. So let's go through this quickly. Okay, so the first line is contract declaration, as you all know, right? Contract is called metacoin. Second is state variable. You're mapping it. It declares a mapping named balances that maps addresses to unsigned integers, uint. We have already done this before, right? This is very basic at this point. The mapping is used to store the balance of each address in the contract, right? Next is the constructor function. Function metacoin. This is the constructor function with the same name as the contract. Function metacoin and whatever. So this is the constructor function with the same name as the contract. It initializes the balance of the contract creator, tx.origin, to 10,000 metacoins when the contract is deployed. Next is the sendCoin function. Function sendCoin, address receiver uint amount as the parameters, returns bool sufficient. This contract allows the users to send metacoins to another address. So we have conditions here, right? If balances message.center is less than amount, return false. So it checks if the sender has enough metacoins to send. If not, returns false. Balances message.sender minus equal to amount deducted from the sender's balance, right? Balances receiver plus equal to amount, it adds it to the receiver's balance and it returns true if the transaction is successful. Next is the get balance function. This function allows anyone to check the balance of a specific address. And finally, return balance address returns the balance of the given address. So this is the code essentially. This should clear a lot of stuff for you, how this works, how we deployed it onto the mainnet, right? Let's go through them again. So you start with Ganache. So you start the Ganache local blockchain development environment by running Ganache/client. Okay, then you compile your contracts, compile the Solidity contracts using the command truffle compile. Okay, then you deploy this to your local blockchain. Deploy the compiled contracts to the local Ganache blockchain using the command truffle migrate network development. Then you deploy it to testnet, which is testing out beta version, right? You have tested it on your own device. Now you test it on beta version. So deploy the compiled contracts to the Ropsten testnet using the command truffle migrate network Ropsten. Finally, you release it on the App Store to the public and deploy it to the mainnet. Deploy the compiled contracts to Ethereum mainnet using truffle migrate network mainnet. Okay, so we'll just go through a recap of key points. So first is development environment setup. You have to ensure that you have the necessary tools and frameworks installed to begin developing and deploying smart contracts, such as local blockchain, Truffle, Web3.js, right? You have to install all of these first. Next is deployment automation. So you write a deployment script to automate the process of compiling, migrating, and deploying a smart contract, making the entire process more efficient and less error prone, right? Okay. Third, you do local blockchain testing, which is you deploy your smart contracts to a local blockchain environment for initial testing and debugging before moving to public networks, right? You always test on your own first. Next is testnet deployment. You deploy your smart contracts to a public testnet, such as Ringpy or Opston. There are more also, right? As I named in the video, to further test and validate your contracts in a more realistic environment. Next is mainnet deployment. Once your smart contracts are thoroughly tested, deploy them to the Ethereum mainnet for production use, ensuring that they're secure and ready for real-world transactions. And finally is verification and interaction. Verify the deployment of your smart contracts and interact with them using tools like Etherscan and Web3.js, ensuring that they're functioning as expected. An interactive exercise or quiz for you, right? This will focus on what all we have covered today. So your tasks will include setting up a development environment with Node.js, NPM, Truffle, Ganache, writing a deployment script for simple smart contract. You deploy this to a local blockchain using Ganache, then you deploy it to a public testnet. Verify the deployed contract on Etherscan, and you finally interact with the deployed contract using Web3.js. By doing this, you will gain a practical experience with the entire smart contract deployment process, right? From beginning, from the setting up of the development environment to interacting with the finally deployed contracts. So I think that's it for today. Thank you very much for listening and see you in the next one.